Hi, hello, welcome to Mickey Tiki. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran, from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and continuously watching my videos. Today's topic of interest is fins. Generally, the fins are called an extended surface which conduct thermal heat energy to the surroundings. So this is the function of a fins. So it should be it is been a extended surface, and it conduct the thermal energy to the atmosphere. And the extended surfaces, the root of the extended surface is placed where the heat is more, and uh, the end of the fin is at the surroundings. So it propagates the heat, and it will provide a better cooling to the heated surface. So generally you can see the fins in the forms of either a straight or a variable area or an annular section or a conical section. So these sections are effectively conduct the heat. So these sections are being used for fins. If I say fins, you have to remember the Bayat number, because the of the fin effectiveness of the fin should be depends on the Bayat number. The Bayat number of the fins are generally less than 1. We know that the Bayat number is we know that HL by K, HL by K. So these thing we have to know better. And Bayat number, it is for the solid surface like fins. So you have to remember these points before get into the fins. Before get into the fins, you have to know these things, because HL by K, it is H is the thermal conductivity, sorry, heat transfer coefficient, K is the thermal conductivity, and L is the characteristic length. So these things will help for the fins for better effectiveness. And for the fin material, the conductivity is less than convectivity. So we have the resistance to the convection is more than resistance to the conduction. That is why the fins are having very high thermal conductivity and very low heat transfer coefficient. That you have to remember. And the applications like a radiator in an engine or an heat exchanger, so these are all the fins. It conduct the heat energy from the copper pipes to the surroundings. And mostly you can see the fins in an every engines. If we have a two-wheeler, you can see an extended surface like this. A fins is being propagated from the engine in order to give a better heat transfer, better cooling of the engine. Let us assume that without a fins, what happened for the two-wheeler engine? So the heat conductivity is very less and the engine will get fail. So fins are one type of a cooling systems provided in engines. So air cooling is definitely depends upon the fins. So with this introduction about the fins, I would like to move on the theory, the important points I have taken from the fins. Generally, fins fins means you have to know the Bayard number. If I say a shortcut, we all know FB, that is Facebook. Facebook means you have to remember that fins Bayard number, FB. So F and B, fins means Bayard number is important. So what is mean by Bayard number? Bayard number is the formula having HL by K. So here it is thermal conductivity, here it is heat transfer coefficient, here it is characteristic length is there, and this is for the solids. The Bayard number is for the solids. This you have to know for your betterment of understanding. Bayard number is for a solids. Bayard number is for solids. Okay. So generally fins are called extended surface, it having a high thermal conductivity, low heat transfer coefficient, and the fins are generally short and thin fins are being used for better conductivity. You have to remember this, you have to notice this. Fins are generally Fins are generally a short and thin. Short and thin. You have to remember that. Okay. Then the effectiveness eta is equal to 1. Then heat transfer rate will be unaltered. So the effectiveness should be either greater than or less than equal to 1. Then only we can get an altered heat transfer rate can be altered. If it is equal to 1, we cannot alter the heat transfer rate. For the fin material, the convective resistance is more than conductive resistance. Therefore, R convection is greater than R conduction. So, for good effectiveness, the Bayard number should be less than 1. Then you have to remember these things. The efficiency of the fin to the effectiveness of the fin is equal to the cross-sectional area of the fin divided by surface area of the fin, that is AC divided by AS. If the fins are thin and closely spaced, then your effectiveness is greater than 1. The thickness of the fin should be small, so that you have to remember. So why we are using thin and closely spaced fins? The effectiveness is greater than 1, so we can use the thin as well as closely spaced fins. Whereas heat flow will be increased if Bayard number is less than 1. What happens if the Bayard number is less than 1? So the heat flow rate will be increased, will be more. If Bayard number is equal to 1, heat flow rate will be decreased. And the fins are more, if you can see the fins, the thickness will be high at the root and thin at the top. So that is how it is being used. As fins are generally a tapered cross section is being used. Next, we are going to see what is meant by an effectiveness. Effectiveness, when effectiveness is equal to 1, the heat transfer rate can be unaltered, that I have given. And the formula for the effectiveness is the square root of Kp by Ha, where the slope is different from the effectiveness. So m is the slope, that is Hp by Ka. So these things I have remembered by means of one of my friend KP Srinivasa Perumal. He always used to draw the drawings in HP pencil. So I have remember these two things. My friend is there. His name is KP Srinivasa Perumal. He always draw he always draw the drawing using HP pencil. He is very good in drawings. So KP is an effective person. So KP Srinivasa Perumal is an effective person. He is excellent in drawings. So he always use HP pencil for drawing any drawings. Drawing means definitely the slope is there. So for the slope HP by KA, whereas for effectiveness KP by HA. So this thing I have to remember by means of a hymn. The effectiveness is K into M divided by H. So K is the uh, heat transfer sorry, thermal conductivity, and M is the slope and H is the heat transfer coefficient. From this equation we get the formula. If H is equal to Km, then effectiveness is equal to 1, that is heat transfer is unaltered. The applications of fins like economizer in steam power plant, that is air side we are using, automobile radiators, air cooled engines, transformers are the some of the applications of fins. Let us go with the assumptions of heat flow through fins. The assumptions, like, we assume that in the fins a steady state heat conduction has been there is no internal generation within the fins, internal heat generation within the fins, therefore no internal heat generation. Uniform heat transfer coefficient we are having. The material used for fins is homogeneous and isotropic material, and heat contact resistance is being neglected, and heat conduction is one dimension, radiation is neglected. So like that we use these assumptions. Please make a note, these assumptions are very very important. You have to know for solving the fin problem. Radiation we are going to neglect. Heat conduction is one dimension. The material used is homogeneous and isotropic material, and thermal contact resistance is neglected. Uniform heat transfer coefficient, steady state heat conduction, there is no internal heat generation. These things you have to notice this. And generally the fins are characterized by the three types. One is infinitely long fins, finite length with insulated tip, that is adiabatic tip, and finite length with non-insulated tip. For this the temperature distribution, slope, heat heat conductivity, and efficiency, effectiveness, all the things I have given here. The Q means small q is equal to capital Q by A. So heat transfer by area. So heat transfer to the area. So that is we indicate it in a small q. So heat transfer per surface area. Heat transfer per surface area I have given. First we have to go with the thermal distribution. The thermal distribution is nothing but the theta by theta naught, that is T minus TA divided by T naught minus TA, where T is the temperature, the surface, TA is the ambient temperature, T naught is the fin temperature. So the infinitely long fins theta divided by theta naught is equal to e power minus mx, whereas for the finite length with insulated tip, that is cos h into m into l minus x divided by cos h into ml, where l is the characteristic length, x is the distance from the tip. And for the finite length non-insulated tip, cos h m into lc minus x whole divided by cos h into ml. For the heat transfer by surface area, for the finite long fins, square root of hpka into uh, T naught minus TA. T naught minus TA. This is the formula from the equation that is Q, that is equal to Q by A, that is the effectiveness into temperature del T. So this is the formula. So this is the formula. Sorry, it is not an effectiveness. I hope it is not an effectiveness. Okay, Q is equal to Q by A, that is equal to root of HP Ka into del T. So this is the formula. Okay. Whereas for the finite length of the fins with an insulated tip, HP square root of HP Ka into T naught minus Ta into tan H into ml. And again for the non-insulated tip, finite length and non-insulated tip, square root of HP Ka T naught minus Ta into tan H m into Lc. The efficiency is the ratio of actual heat transfer to the maximum heat transfer. The efficiency of the fins is defined as the ratio of actual heat transfer to the maximum heat transfer, where for the infinitely long fins the efficiency is equal to 1 by m into L, where for the finite length tan h ml divided by ml, where non-insulated tip tan h mlc divided by m into lc. The effectiveness is the ratio of heat transfer per surface area with fin to the heat transfer by surface area without fin. So that is the effectiveness definition. Therefore, for infinitely long fins, which is nothing but square root of Kp by Ha, and finite length with insulated tip, that is square root of Kp by Ha into tan H ml. For non-insulated tip, square root of Kp by Ha into tan H m into Lc. So here m is the slope of the heat transfer line, and the theta by theta naught is the temperature distribution. So with this, I'm going to complete the today's lecture about the fins. I hope I have given enough details about the fins. So if I found anything new on the fins, I will give it later. So if you have any doubts, please let me know in the comment section. I will put another video for clarifying your doubts. And if you like my video, please like, share and subscribe Makey Techie for continual updation about the mechanical engineering topics. So with this, thank you once again. Thank you all, and bye bye from Santhosh. Thank you.